Okay, so today we're going to be talking about relation versus function. First of all, what is a relation? A relation is a set of input and output values. Okay, it's like a relationship. You have an input and you have an output. So if that's a relation, what makes a function different than a relation? Well, a function is now a relation, but with certain rules. Okay? So a relation can be anything. It can be the sun and the sky have a relationship, correct? It can be any input and output values in an equation. But now a function, it is a relation, but now it has some rules placed on it. And we're going to talk about those rules here in a little bit. First of all, what are the components of a function? Okay? First of all, we need to see what the components of a function are. Well, first of all, a function has to have an independent variable. That's the x value. That's the input value. We've talked about independent and dependent, so it keeps leading up. We're building on independent and dependent. So it also has to have a dependent variable, which is the y value, or also f of x, which we talked about today in class, and y is the output. So just like we talked about in class, y is depending on x. Y sits around in an equation and waits for the x value to change, the input to change, so that it can get an output. So y becomes the output. Make sure you write this down. This is very important and you should be taking your notes. Now, let's talk about the rules of a function. What makes a function different from a relationship is, number one, there is a one-to-one relationship between x and y. What do I mean by one-to-one relationship? Well, I'm going to write this down too. For every x, there is a unique y. There's only one y. Okay? So that is what it means when we say one-to-one relationship. Okay? It's a one-to-one relationship between x and y. Okay? Rule number two. The x's can't repeat. And we'll take a look at some examples, but the x's can't repeat. And you're going to be chanting this, and Miss Applegate and I will probably be singing it to you for those of you that have her. The x's can't repeat. The x's can't repeat. The x's can't repeat. The y's can do whatever they want, but the x's cannot repeat. And you need to make sure you're writing these down. Again, the x's can't repeat. Oops, excuse me. Now let's go to the third and final rule. Okay? It must pass the vertical line test. Now, what is a vertical line? A vertical line is a line that's up and down. Ooh, I don't have my pen. This is a vertical line. And this is going to apply to graphs. The vertical line test is going to apply to graphs. The x's can't repeat can apply to a graph, can apply to a table, a mapping, and a list of input and output values. Okay? Now, there's different representations of functions. We're going to see a graph, we're going to see a table, we're going to see mapping, and we're going to talk about a set of ordered pairs. Okay? I think we might even see set notation. For equations and verbal, that's going to be the next video on Monday. Alright, let's start. Here we have what? We have a table. Okay, we have a table. And it's asking us, determine if the following relation is a function. Okay, so rule one is there has to be a one-to-one relation between x and y. Rule two, the x's can't repeat. So we can use that here, the x's. Let's look at our x values. We don't care about the y. We're going to look at our x values. Are any of those numbers repeating? I have 3, 9, 15, and 21. No, they are not repeating. So yes, this is a function. See how easy that is? Now look, I have a set of points in the function. So I'm going to be looking at my x values, x value, x value, x value. I don't care, right here, I see, look, a y and a y that are the same. I don't care about the y's. I don't care about these. It's the x values that I care about, okay? It's the x values that I care about. And what do I notice? I have a -2 and a -2. So what's happening here? My x's are repeating. So is this a function? No, it is not a function. Okay? Here we go. I have another set of points. Okay? I have another set of points. So I'm going to circle my x's. Okay, again, look. I have a y repeating and I have a y repeating, but I don't care about the y's. What I care about is the x's. Do I see another -1? No, that's good. Do I see another -2? No. Do I see another +1? No. Do I see another +2? No. These are all unique numbers, -1, -2, 1, and 2. So yes, this is a function. Now let's go down to this table right here, okay? All right, so let's go down to the table. Now, here are my x's. Remember, I don't care about the y's right now. I don't care what's going on in the table. But what do I notice? What's happening with my x's? My x's are repeating. So, is this a function? No, 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 no. All right. This right here is called a mapping. Okay, a mapping. It's going to map x's to y's. That's why you're seeing these arrows going from -2 to -9, 3 to 6, 3 to 8, 4 to 7. We're going to do the same thing. We're going to look at our x values. Okay, we don't care about the y's right now. Let's look at our x values and let's see what's going on. All right, so -2 is going to 9. Perfect. 3 is going to 6. 3 is going to 8. 4 is going to 7. Is this a function? What's happening here? The 3, I have 2 lines coming out of the 3. So if we were to write that, if we were to write this mapping in a table, I would have x and y, so I would have -2 going to 9. I would have 3 going to 6. I would also have 3 going to 8. I would have 4 going to 7. So what happened? Boom, boom, 3 is repeating. See, the line is coming out twice. So this is a big fat no. Now, this one. This one's a good one. This one I love. Because here now I have a set notation. Okay? Here I have notation right here. It's telling me that all my x values, all my independent values, all my input values are 7, 8, 9, and 10. Right? Oopsie. Okay? And then all of my output values are 11, 13, 15, 17, and 19. So is this a function? All 13, 9 can go to 15, 10 can go to 17, but what's going on here? I have an extra y. So what's going to happen? What's going to happen? That means that one of these numbers has to map to 19. One of them. It doesn't matter which one, but one of them has to map to 19. So what's that mean? That means that the 10 is going to the 19 and the 10 is going to the 17. And like I said, it doesn't matter what you map it with. All I know is there's only 4 x's, but there's 5 y's. So that means that one of these is going to have to repeat. So this is a big fat no. It breaks the x's don't repeat rule. So now let's look at some graphs. Okay, here's where it's going to get fun. This is what I like. Here's where it's going to get fun. Okay, I'm going to draw a line, and I hope this is straight. All right, there it is. This is my vertical line, okay? This is my vertical line. Now, the last test said it needed to pass the vertical line test, okay? Let me grab it. Come on, let me grab you. Hello. Doesn't let me grab it. Oh, mercy. Okay, so I got rid of the line and I brought over my ruler, okay? So the ruler makes a vertical line. A vertical line is up and down. So now, what we're going to do is we're going to run it over our graph. And we're going to determine if any of the points touch the ruler at the same time. So this is our x-axis right here, right? That's our x-axis. So we're doing the same thing. We're checking to see if the x's are going to be repeating. If the x's are going to be repeating, then they're going to touch our line at more than one point. So what I'm going to do is I'm going to drag my ruler over to see if I run across the graph twice. Okay. Did it pass the vertical line test? Did I touch any point twice? No, I didn't touch any point twice. So yes, this passes the vertical line test. Now, let's check this one. Now, remember when we were doing inequalities and we talked about the open circle versus the closed circle, right? The closed circle meant it includes the number, right? The open circle does not include the number. Okay, so what this means is that this is a -1. That means the -1 is not included here. So if you run your ruler over it, it looks like right here. Do you see how they're on top of each other? Normally that would tell us that the x's are repeating. However, I have an open hole and an open hole, which means it's not including the number. So in this case, it's not repeating. And then once I go over the graph, I'm fine. I don't come across, I don't touch this function in 2 places. So yes, this is a function. Now, remembering what we just did, this means open. So let's give these numbers. This is a -1. This is a -5, and this is a -10. Okay? So this right here is not including the number. This is not including, but this is. Not including, but this is. Not including, but this is. So this, when we run over, boom, we're touching. We're touching this twice. They're exactly on top of each other. However, this is an open hole, so we're not including that -5. This one is including -5, so it's only being used once. Same here. Oops. Same here. This is only being used once. This is only being used once. So this is a function. Let's go down. Now, what do you think about this one? If you run the ruler across this function, are you going to touch an x value twice? Are you going to touch the function twice? Let's see. And I close. Okay, so I'm going to leave that up to you. So if we run over the function, do you touch it twice? I'm frozen. Okay, sorry guys, I got frozen. So let's run this over. Uh-oh, what happens here? What happens? I'm touching twice, right? I'm touching right there and right there. And then I'm still touching. Look how many times I'm touching this function twice, even down here. I'm touching it all over the place. So this is a no, right? So now let's go over here. What do you think about this one? Is this a function? Well, look, here I go. I'm going across. I'm going across. Have I touched anything twice yet? Have I touched anything twice yet? Actually, no. I didn't touch anything twice. So, yay! This is a function. Oh, what about this? Let's see what it says. What point could be removed from the graph in order to make the graph a function? So, all right, we have all these points. So you can use your ruler, excuse me guys, you can use your ruler to go across and find if anything touches twice. Does anything touch twice? Does anything touch twice? And if it does, which point could you remove? Well, here it is, B and D. B and D are directly on top of each other. So if you removed B or D, you would have a function. Yay! The end.